Aloha, this is Richard Halverson. This is ITS148, and today is February 9th, and we are going to start chapter 13 today, which is inheritance. And so let me share my screen. Okay, so let me get this out of here. Get this right up there. Okay, so here we are. This is the 148 syllabus, and so we are in this 5th week, inheritance. So today I'm going to cover. I think I might be able to cover pretty much all of chapter 13. Let's see. So if we look at the textbook, chapter 13. Inheritance. All right, so this concept of derived classes. Okay, a class will commonly share attributes with other classes. Let me try out this presentation mode. Okay, the concept of a derived class. You can create a class from another class. Let's say that you want to create a new class, but there's another class that has everything that you want, where that class has everything that you want your new class to have, but you have some more stuff that you want to add to it. Well, you can derive your class from that other class, and that's the concept here. So let's say a store inventory system has a class called item, and it's got a name and it's got a quantity. It's got a name and it's got a quantity. Now, we can create another class called produce, which is derived from item. Produce will have everything that item has in it, plus it'll have an expiration date. Okay, so the way we define that is we say, okay, so first up here, here's item, and here are the attributes of item, the properties, and these are some methods. You can set the name, you can set the quantity, and you can display out the item, information about the item. Now, defining a new class called produce, derived from item, we basically want all of the everything. When we initialize produce, we want to do all of the initializing of item, but then we also want to define and set this additional property called expiration to a blank. And then we also want to add a set expiration method and a get expiration method. Okay, so it's that simple. And here we're showing you how we're creating a new instance of an item, and it's like it's serial, and it just has these properties. But then we're going to define another object called item 2, which is going to be a produce object. And so here we're not only setting the name and the quantity, which are methods that come from the fact that it's an item, but we also set an expiration, which is specifically because this is a produce type object, and so we have these additional set expiration and get set expiration. This extra set expiration method, when we want to display out this produce item, we can use the display from item, but then we also probably would want to display out the expiration also. So right underneath the display from item, we would have another print statement that looks like this. And so it would end up printing out like this. Okay, so cereal would print out like this. Apples, executing this statement, would print this out. But then additionally, we would add this print statement underneath, which has this information. All right, so so this explains all that. This participation activity, which you want to click through, shows how as each of these things are executed and created. It's good to see how that goes. You should click through this, which sort of shows that click through it here, I'll show you. It shows what happens as these are executed. So when this is executed, we're creating an instance of an item, and these properties are defined, and these methods are available for use. And when we execute this produce, creating an instance of a produce item, we see that not only do we see the item attributes up here, but also the additional ones that come from produce. Okay, anyway, this is something that you should probably learn. It's called the Unified Modeling Language Notation, and it's a way of describing this derived class relationship. So we have item here, and we see that the name of it is item, and we have these properties, and then these methods, and then we have this produce class that's derived from item, and so that's what this arrow indicates. And then we only show underneath the ones that are in addition to the class from which this is derived. So produce has, in addition to name and quantity, it has expiration, and in addition to these methods, it also provides these two methods. So you should know that. And so here, this shows the inheritance of these different attributes, properties, and methods. So an item, when you just click an item, it's these methods and these data attributes. When you click on produce, you see we not only have item, but we also have a couple extra ones from produce, expiration, and this and that. And then fruit, we got more has seeds or doesn't have seeds. We got dairy, which is percent fat content or whatever. For a book, for example, it's still an item, but we also have title, and it can be a textbook, which has got an addition, attribute, a title and addition, and an audio book has a reader usually, I guess. So you should derive a class that can serve as a basis for another class. Is called a base class. Class dwelling has a method called this, and house is derived from dwelling, and it also has this method and this method. So after this is executed, how many different methods can H, which is an instance of house, how many different methods are available to it? Well, not only the ones that come along with the fact that it's a house, but also house is derived from dwelling, and dwelling's got this open door here, so the answer must be 3. Okay, here's a challenge activity. Let's see what this is. It's on derived classes. So we have this class called a vehicle, and the only property is that it's got speed, and you can set the speed and you can print the speed. And then we have this other thing called a car, and that's derived from vehicle. So this car not only has what vehicle has, which is speed, but it also has a special print statement, I guess. Yes, it's a special print statement, which will put something before the printing of the speed. And so here we have creating an instance of a car called my car, and we're going to set the speed at 40, and then we're going to execute the my car print car speed method, which is this method. It's not this method, it's this method. Well, so when this method executes, first thing it does is it prints this thing, that's this here to there, and then it prints whatever this is, which is simply whatever this is, which is whatever the value of this is, which in this case would be 40. So that's why it looks like that. And because of this is a regular print, and that's why it prints a new line. Okay, so what does this do? Oh, start. 0, speed to set, self speed, driving at 25. Okay, we're going to have this, copy, paste, and then we're going to have 25 and that. Oh, that's nice. Okay, what's next? Ooh. Let's see. We have a vehicle, a car, and we have an animal-powered vehicle, which has got a speed, no doubt. It's derived from vehicle, so it's got a speed, and we can print the speed. It's got an animal property, and it'll print, when we're printing animal speed, it first prints the name of the animal, or whatever the animal attribute is, followed by speed. There's a space there because it's just a comma, and a space here, and then okay, and then the speed. Okay, so chariot is the animal is donkey. The speed is 3 for chariot. For my car, the speed is 60. And here we're printing my car speed and we're printing animal speed. Well, I guess it's going to be driving at :space 60, and then it's going to be donkey speed is 3. I think that's right. Let's see if it is. It is. Great. What's the next one? We have car is derived from vehicle, and we have electric car, which is derived from car. Okay. And okay, so we create an instance of an electric car. We set a speed, and we set a battery level, and then we print the car speed, and then we print the battery level. Well, it's just going to be car speed is going to be print car speed is this, driving at something, driving at the car speed. And then it's gonna print the battery. Well, yeah, so you can do that one. All right, what's this one? Set course student's last name to Smith, age to 20, ID to 999. The output looks like this. Okay, and it's about inheritance. Okay, so we have we define a class called person data, and it's got some stuff. It's got a last name and an age and a years and some ways to something. And a way to print it out. Not really printing it, just returning it. Returning a string. Okay, so we have student data, which is derived from person data. And so that's going to add an ID. Okay, that's it. Okay. So we're supposed to do something here. And when we print this out, or when we get this string, it's going to be this string. And so it's going to print out a name. It's going to print out an age. And I guess I don't have to. I just do assignment statements. Okay, so course student dot something. No. Let's see. This is the challenge. Course student. There's last name and there's years. Last name and years and ID. Okay, so last name, years, ID. Okay, so last name. How do I set the last name? Oh, here, set name. Set name. Set name. And I'm going to set the name to Smith. And then do I got to set the age or something? I guess so. Age is 20. I'm going to use age years. Set set name and set age. Yes, set age. Set age. Okay. Course student set age is 20. And finally, using this one, set ID, course student set ID equals okay, anyway, you can try that. That looks like that might be something pretty close to working. All right. Accessing base class attributes. So I got to remember an attribute is both a property and a method. Derived class can access the attributes of all of its base classes via normal attribute reference operations. An attribute reference is resolved using a search procedure that first checks the instance's namespace, then the class's namespace, then the namespaces of any base classes. And the search attributes, the search continues all the way up the inheritance tree. Okay, so it's pretty obvious how this works. It starts it starts with the closest definition. It finds the closest definition, and that's the one it uses. It's not the first definition, it's the closest definition. So, so we have a transport mode, and we've got an info, and we've got a motor vehicle, which is based on transport mode. And it's got an add fuel and a drive. Then we've got a motorcycle, which is based on motor vehicle, which has got a wheelie. Well, anyway, so you've defined something, and let's say you've defined a motorcycle. So you've defined a couple motorcycles here, and you're trying to figure out, you're calling these methods, and how does it look for these methods? Well, first it's going to look, a scooter is a motorcycle. So first it's going to look in the namespace of motorcycle to see if it finds info. If it doesn't, then it's going to look in the namespace of what motorcycle is based on, which is motor vehicle, looks for info, doesn't find it, and then it looks, so then it's going to look for the, for here, and it finds it there. Well, that's pretty obvious. But if there was an info defined here and another info defined down here, and then it would be this info defined down here, okay, because it's the first one. As you're going up, as you're going up the tree, the inheritance tree, the one, here would have been the first one. That's not this case though, but I think we have an example of it. And here this says to extend it. So this is an exercise where you're going to extend extend the above example with by adding an airplane class, which is derived from transport mode, and it's got the airplane has got add fuel and fly as methods, and a property of number of passengers. And then there's a jet plane class, which is derived from airplane, which is, and you're supposed to add some other stuff. So anyway, that's a good exercise. I'm not going to do that right here. Searching for attributes in the inherit. So inheritance tree describes the hierarchy between base and derived classes. I guess it does. Evaluating this searches this, then this, then this. No, it's the opposite. First, it's going to search with motorcycle, then it's going to search motor vehicle, then it's going to search this. So the answer to this is false. Adding a new derived, when adding a new derived class, a programmer has to change the base class as well. No, well, someplace up here it says explicitly, you don't have to change it, the base class. So this would be false. All right, you can override class methods. And so that's kind of what I was referring to previously, where, here we've got, for example, we've got in the base class of it, we've got an item, and then we have something, a class called produce, which is derived from item, and but they both use this, they both define a method called display. So obviously, so here, when we define the produce class, the produce display overrides the item display. Produce is derived from item, and item's got a display. got a display method, but that's not good enough for produce, so produce overrides it with that. All right, so you can all, here we show produce, the produce, having two separate print statements, but really, let's see, is this right? Display. Yeah, that's what's overwritten. Doesn't quite work, but so this produce display can, it's overriding the item display, but it can actually use the item display if it wants to. And the way it does that, it shows here where the produce display actually calls the item display first. And then after that, it does the additional thing of printing that out. So see, you can even do that. This is overriding base class methods. Assume my item is an instance of item and my produce is an instance of produce with classes item and produce as defined above. It asks this will call the display function for item, obviously. This will call the display function for produce, obviously, because this is an instance of a produce class, and this is an instance of an item class. Provide a statement within display method of the produce class to call the display method of the produce's base class. Well, the produce's base class is item, so it would be just display, I guess, something like that. Something like that, I think. Go. What did I do? Oh, I got to put the self there. Don't forget to include self as the argument. Okay, anyway, all right, so produce did not have its own display. Well, what happened? If produce did not have its own display, then it would just use items display. All right, so what is this one here? This is so define a member method called printOff for the pet, for the class pet data. Make sure you use the base class's print all method. Okay, so the sample up for the Fluffy is 5 years old and ID of 4444. So we've got animal data, Fluffy, 5 years old, ID. And this sets it. So here we're supposed to make a print all. Okay, and we want to use that one. So I guess I'm going to do something like solution goes here. Something like def print all. Self, I'm gonna put that in here, I guess. Right, just like up here. And the first thing I want to do is I want to use this print all, animal data print all. itself. And then after that, I want to print out the ID, don't I? Yes. So here I want to print out the ID. So anyway, you can finish it. This should call this, and then this is going to first call this, and then it's going to print out the ID, which you're going to add there, which is going to print out this line. All right. So anyway, so you can finish that. Okay. So okay, now we've got. Oh, this is. I don't need to. Okay, I don't have any I'm not confused by is and has, but I guess if you're learning it from, I mean, I guess if this is all brand new to you, I guess you can kind of have a confusion about this. But the concept of inheritance is often confused with composition. Composition has a relationships, and inheritance is a thing. So, here we have a mother. Okay, so here's a class called object. Here's a class called mother, and they're two different separate classes. And so child has a name, and child has a birth date. Child has a so these are all has-as. They oh, a mother can have child mother can have child objects. Mother has can have child objects. In other words, this can be a list of child objects, but there's no but still we're not talking about inheritance, because nothing is derived from anything. There's no base class or anything. Inheritance is something different. You have a base class, which is a person, and you can have a child, which is derived from person. You can have mother, which is derived from person. And so this is a child is a person, and mother is a person, not has a. Is a versus has a. Fruit, pear is a fruit. House has a door. Dog has a owner. Mug is a cup. It's pretty easy. Okay, now, as you might have suspected, you can always, or you can base a class off of, or a class can be derived from more than one class. There can be more than one base class. This is multiple inheritance. Okay, so we can have, for example, a vampire bat can be based here. A vampire bat can be based on two classes. So it inherits everything to do with a winged animal and everything to do with a mammal. So it's depicted like this, where you have it's two arrows, winged animal attributes, mammal attributes. So vampire bats got everything. And so so there's that. There's also this concept of a mix-in class, a mix-in class. It's a class. It's a class intended to provide some additional behavior, as far as like new methods, maybe, but they aren't meant to be instantiated by themselves. Okay, they aren't meant to be classes used by themselves. They're just intended to add some functionality or some properties, some attributes. So so here we've got a driving. So here we're talking about like transport modes, and we can have certain certain modes that you drive, and certain I guess on the road. and certain ones that fly. And so you have a transport mode, and then you want to derive a new class called semi-truck, and it's going to be a transport mode. It's going to be derived from transport mode and drive and the driving mixin. A flying car would be from 3. You would want, not only the flying mixin but the driving mixin. Okay, so anyway, so that's pretty cool. So you can do that too. Here's a nice participation activity that you can figure out. Based on what each of these classes, derived classes, base classes give you, then you can figure out by these methods here, which come from these, which one goes to which. All right, testing code. Okay, so this is, unit testing. There's a standard library unit test module, which can help you do unit tests to test on different classes. So, excuse me. So we will revisit this later. Starting now in this semester, we'll be using these because we're going to be doing a lot more coding with classes, and testing is going to become more and more important. And so we'll see how these are used. All right, so let's do some labs. It's 410. And all right, what's the first one? Lab, pet information, derived classes. Okay, so we have a base class called pet, which has these attributes, name and age. And we have a derived class called dog, which inherits everything from pet. And it also contains a breed attribute. So we're going to complete a program to create a generic pet and print the information using print info, and then create a dog pet and use print info to print the dog's information, and then add a statement to print the dog's breed attribute. Okay, so how does this look? Okay, the input's going to be a pet Dobby, pet named Dobby, and 2 years old, and then another pet called Creature, 3 years old, and Creature is a German Schnauzer breed, must be a dog. Okay, so the first time it prints this, the second time it prints that. Great. Okay, so this is the code to do it. So we have a pet and a couple of properties there, a name and an age. And then we've got printing out the info. Now, then we have a dog. It's derived from pet. We initialize it. First, we initialize what's in pet, and then we add this self-breed, this self.breed, this breed property. Okay, that's it, huh? Oh. All right, so oh, okay. Oh, okay. 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 So I've created create a generic pet. Okay. Well, I've already created a couple. I've already created the my pet, and I've already created the my dog, and then I've asked the user to enter these 5 things in, and that's these 5 things. these 5 things. Copy this, paste it down here. That's where I'm going to paste. So we're going to be asking for these 5 things. And the first thing we want to do is to create, okay, so I guess I'm just going to say my pet dot name. Is it name? Yeah, I guess it's equal to, this is a property, so it's not a, so there's not a method to set this. I just set it this way. Equals whatever was read in here. Okay, so I've defined that. And then I also have to do the age. My pet. My pet. And then we got my dog. My dog. My dog. My dog. This is age. No, is it age? Age. And this is going to be my pet. Print info. Okay, that's the method. And then let's see, I don't need this. My pet dot name is equal to pet name. I'm doing this, but yeah, this. Okay. So these I just set. These I just have on the left side of an assignment statement. This is a method that I call left side of an assignment statement. So I also need to do dog breed. Dog breed. It's dog breed, this one. Okay, so dog name is the dog, my dog dot name is this, age is that, breed is that, which was read in here. Dog age, print the info, and then I also have to print breed. Print breed is my dog breed, something like that. Let's see what this looks like. Looks pretty close. You know, you can fix that. All right, what's next? Add instrument information, derived classes. Okay, so we've got a base class called instrument, and we've got a derived class called string instrument for string instruments. So we've got a, okay, we've got drums and manufacturer. We've got a guitar and a manufacturer. We've got a year built and a year built and a cost and a cost. Oh, but with stringed instruments, we have number of strings and number of frets. Frets. Okay. What a violin? Number of frets would be 0, I guess. Okay, and so this is drawn, okay, frets 16, okay. All right, so what are we supposed to do? Oh, we're supposed to make the program that does this, okay. So here we got some nice creating an instance, printing it out. Creating an instance. Okay, so let's do some data here. I'm going to take this and I want to copy it. And I'm going to paste it down here. Paste. And excuse me. So here I ran it. Here I created an instance, print info. Where am I supposed to? Oh, here. All I got to do is okay. So what comes in? Guess I got to do a def init. Parentheses. I think I need all this stuff. So I'm just gonna copy, paste, and in addition, I think I need name, manufacturer, year built, cost, these two things, these three things also. Copy, paste. Okay, so those things are coming in. And the first thing I want to do is I'm gonna take care of this. I'm just gonna take care of these things right here. Okay, that's taken care of. And then I need to do whatever I need to do for the self num strings equals I don't know. Oh, num strings. You know? Oh, no semicolon. And then just to copy, paste, and num frets. Copy, paste, paste. Okay. What does this look like? Anyway, that's pretty close. All right, what's next? Lab course information. So we've got to define a course, base class, and then define a print info. And then we're going to define an offered course. It's got this, and this. Okay, so we got this class, and then we got this class, this. Okay, this is just a plain old class. This is another plain old class, but it's not only a course. I'm sorry, course. It's an actual offer. It's an actual offered course. So it's got these three additional things down here: the name, the semester, and the time, class time. All right, see, so there's two of them, 1, 2. And here we're supposed to put, we got to put everything. Okay. So, oh, and we're doing this. That's great. Okay, so the first thing we got to do is some kind of constructor. And so I'm going to just, well, I'm going to cheat. I'm sorry, I'm going to cheat here. Why? Because I like cheating. I'm going to open up another, what is this? Okay, I got a nice blank, nothing here. And something else I'm doing. Something else I'm doing. Let's put this over here. And put this here. And this is 13. I'm going to go back up here. And it's all here, isn't it? Okay, good. I'm going to take this. I'm going to do Control A and then Control C and Control V. Okay, here's the code I was just working on. And now I'm going to go down to the one I'm supposed to be working on. And I got something that looks like course, which something looks like this. And it's got to have these two attributes. So I'm going to take this. Take this, copy, paste. But it's just going to have these two things here. And underneath, I'm going to have something that looks like this. Copy, paste, paste. There's there. And then the print info, it's got to look something like this. Print info. I'm going to have something that looks like this. And I got to have something that looks like this. And something that looks like this. Okay, and what is got to be in there? It's got to look like this. Course information, course information, and course number. It all indented in like that. Course number. And what's going to print out is going to be copy, paste. So course number is going to print out and course title will print out. So now I can just take this, copy, enter, paste. This is title. Oh, gee whiz, title. And this is title. Copy, paste. Okay, that should do that. And now I got to do another one here, and that's going to look a lot like this. I'm going to have this there. It's going to look more like copy, paste. And it is going to have this in there. And it's going to have going to have this. Copy. Course dot paste. First, it's going to do that, and then we're going to do instructor name, instructor term, and instructor info. Oh, class time. Sorry. Class time. Does that look kind of like this? Yes, it does. And then we need to do this print thing. So I guess that's going to look something like course print info self, I guess maybe. And we don't need that. But this is going to be instructor name. Oh, instructor name. Instructor name, term, and class time. And this is going to be class time and term. Oh, look at how late it is. Okay, so this might be pretty close to what it's supposed to be. Let me just copy this, copy, and paste, and I'm going to just run this, see what this looks like. I don't know, that's pretty close. What's the last one? Is this the last one? Yes, it is. Okay, real quick, let's see what this looks like. Overriding member methods. Okay, so we're going to override something. We got a derived class book and a derived class called encyclopedia. There's a print info that overrides this print info by printing not only that, but also that. So the first one looks like that. And the second one's got the same stuff, but also has these two things. And I guess you're supposed to do it where book, print info. Okay, you're supposed to just add a print info that completely overrides this print info. And basically what that is since you're gonna override the whole thing, you're not gonna use, you know, it's dumb, right? But you're not gonna use that one up there. You're gonna make your own. And wait a minute, you gotta do it. You gotta do some kind of. You gotta have something that looks something like this in there. Let me just copy this. Let me put this here. Yeah, it should look like that. This is gonna back up. Okay. So this is gonna be, you know, title, author, publication, volumes. Title. value. Okay, so you got to finish this, finish that. Some more stuff there, and then this is just going to be like that, and you're going to also add, you know, you're going to add these two. So you're just going to add two more. You know, you're going to add addition and a number of volumes. You know, yeah, that. Okay, so anyway, you know, that should get you to where you want to go. You want to take this, copy, paste, and give it a roll. All right. So anyway, I think this should do it for chapter 13. And next week we can move on to where? Chapter 14. All right. Well, thanks for watching.